Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. Okay, so today I'm going to talk about Docker and the Linux pending topics we'll have after Docker. So that way we'll be in a little bit sync. So the first question is, what is Docker? That is the first question. If someone will ask you what is Docker, then what you are going to say. So next thing, which is before that, uh, all of you have spent time on the kernel, Linux kernel, correct now? Did you get a chance to review that before that?
Yes.
Yeah, good. Okay, so what is Docker? So Docker is a container management tool. Yeah, so it's managing container. So last topic which I said, virtual box. So what virtual box is doing? So virtual box is managing virtual machines, VMs. So Docker is managing a container. So here we have a three word. One is a tool or platform. So tool means what? So we always use a new tool all the time. Why? Because of saving cost. That is something which we have. Save cost. Second thing which we have, save time. And then third thing which we have is improving quality. So these are the three reasons. Now question in my mind is how Docker can save cost, Docker can save time, and Docker can help me to improve quality of my software. How? So here when you see in terms of saving cost, I'll put it in this way. Um, let's say you have X CPU, X RAM, X storage. Okay. So now maybe in this you can run multiple, one physical server or maybe five virtual server. And here you can run, I'm just giving you just a odd way to container. So what is container? I don't know, but here I see that same resources I can run multiple applications. So that way we can save cost. But are we saving a cost or avoiding the wastage? For that we need to know what is a virtual server, which you know that last time we covered. In this session we are covering what is container. Okay, so that is a saving cost. Saving time means, let's say if virtual server, physical server, it takes 1 day to set up or 1 hour, let's say. Virtual server, how much time it takes to set up? 5 minutes. Container, how much time? 1 second. Saving time. So here when you save time for running applications and you save time for you know saving resources and saving cost and saving time for running our application in container, so of course it will help you some way or other way to improve the quality also, because here you save time and here you save cost, both you can put it here and improve the quality of the software. So one thing is clear, this tool will help me to save cost while running application in container, save time while running application in containers, and improving the quality. So here, what is a management? What is management here? So management means simple. Last session, if you have practice, what you do with the VM, VM virtual box do what? So create a VM, start a VM, stop the VM, restart, pause, unpause, and kill and remove. So these are the things you do with the VM. So same way Docker can help you to manage container. So you can create a container using this tool. You can start a container. You can stop the container. You can restart a container, pause and pause, kill and remove. So now I understood that okay, Docker is a this is the benefit you get it. These are the capability what Docker has. But one thing I did not understand, and that is what each container. That is a very important question, and that we need to understand now. So anyone have any questions so far?
No, Raj. So far, all good.
Okay. So let's try to understand what is container. So if you want to understand the container, before that you want to understand the virtual server, which you know that. So let me help you with the visualization. It will be easy for us. So this is a hardware, and on top of hardware, what we have? Kernel, correct now? So this is the kernel, and kernel is having one root file system. Root file system. Root file system means, let me show you that easy way. You will remember that. Windows root file system, Linux root file systems. So have you seen this file structure somewhere? All of you? All of you?
Seen in the sense I've heard about it, but not worked on it. Right?
This is a Linux file system, no?
Linux file system, yeah.
Yeah. Every time you'll log in the Linux, you'll see this one. Correct now?
Yep.
And this is the Windows one. This one. So what is this? This we call it root file system. So you have one root file system, RFS. Okay. After that, what we have? So one network, you get it. Let me one network. So root file system, network,
Work,
and
user,
then
library.
one PID. This is the network. This is the PID map, you can say. Okay. So why I'm creating this image? I'm creating this image because I wanted to tell you, forget about the Docker and forget about the container. Just remember only one thing, and that is how application runs. What are the resources application need to run? Look at this here in Windows itself. All of you are comfortable?
Yes.
So guys, look at this here. Let's try to find out the answer for it. What are the things you need? One applications. So if you look at this here, huh? Let's say there is one application running GoTo. Okay, this is one applications which we are connected to, and this application's PID is this one. It's running. You see one user is required, CPU required, RAM required. So these are the things which you need to run applications. So for every applications you will see it's the same thing. So in order to run applications, you know, Question is, what are the resources needed to run applications? So we need hardware, then we need kernel, and the kernel you get one user, you get it, one user you get it, one network you get it, one mount root file system, and one PID tree, here PID ID, and then CPU need it, then you need a RAM, and so on. This you can say storage also, root file system you call it. So in order to run any applications, these are the resources you need. Correct now? All of you? Hello?
Yes. Yes, Raj. Yeah.
So here one root file system, one network, one PID, multiple user 1, user 2, user 3. This is running Apache. Let me change the color. So tell me, other users will be able to run? User 2 will be able to run Apache? Tell me.
So use when we say users, like multiple user logins, right?
You and me have logged into one
And
Linux box. I started Apache. Will you be
yeah,
able to run Apache?
yeah, we can run multiple instances of Apaches, like in the same server. Correct.
Think about it. Apache is consuming which port number? 80. This will be running in 50 PID
Okay.
and stored it at root file system C Apache. First user. Now tell me one thing. This guy also is running Apache. Will you get 80?
So no,
No.
we'll get
Why
You
no?
50
can, yeah.
You
because
can you run up 50 PID? See here.
no
Proof. No PID is unique. Duplicated.
duplicate. Yeah.
No. And can you store that this Apache in C Apache? No, because file integrity is a problem. Correct now?
Yes.
So we want to, in a data center, think about it. In a data center, what we wanted, we want to run multiple Apache. So isolation is not there. I cannot run 80, 50 and C Apache. So what we got a jugaad, we said, hey, let's not use physical boxes. Let's say use hardware, kernel, hypervisor, then create multiple VM. First day you did it, second VM, third VM, and then in each VM you have operating system, which operating system means kernel, one network, one PID tree, one root file system, and Apache is running here. Operating kernel, here also kernel, here also kernel, root file system, PID, MNT, network, Apache is running like that. Correct now? So one of the reason you got a virtualization technology. So this is a physical server. I cannot run. This is a virtual server. I can run multiple Apache. Understood?
Yes.
So now in this case, virtual server, instead of creating one physical server, I can create multiple virtual server and multiple Apache you can run. That will be making our software available, high availability. Correct now, all of you?
Yes.
So now guys, here, this is outdated. Let's talk about a virtual server. So you see something which is getting wasted here. Think about it. Something is getting wasted here. All of you. So here if you see that this isolation you're getting it application 1, application 2, application 3. But you see here you need to learn multiple operating system here. See here also you have a hardware, I mean kernel. Here also kernel and then VM. VM means hypervisor, and the multiple kernel you have it. So don't you think so this kernel operating system which you run, this also needs CPU, RAM, storage and licensing cost, correct now? What do you think? Hello, what do you think, all of you? I'm audible, right?
Yeah, that's right.
Yes.
So here in order to run 3 Apache, I need to run 4 operating system, 1, 2, 3, 4. And here if I want to run it, there is only one operating system here you have. But the problem is isolation is not possible. I cannot run 3 Apache because one network, one pit tree, one root file system, and so on.
So
Understood the
here when
problem?
you, yes, when you say four operating system, you consider hypervisor is also an operating system, correct?
Hypervisor has to run on some operating system, no kernel.
Oh, okay.
Hypervisor you will run on the kernel only, right? Some kernel, Windows or Linux kernel.
Okay.
Yesterday, last session we did, no? We installed VirtualBox on the Windows machine or Linux
Yes.
machine, correct now? So this is the problem with the virtualization. Now this is the same technology which is used by AWS, Azure, Google Cloud. So what to do now? Then this guy has come. This guy. I mean, it's not a new technology, I must tell you. It's not good to say father or something, but logic has changed, I guess. I forgot the name. That's the reason I'm searching in this guy. His name is Solomon Hikes. Okay. So this guy say came and said, "Hey, can we change the architecture a little bit?" So try to understand that. Very simple though. Okay. Solomon Hikes. He said, think about it. Let me ask you. In order to run one application, you need one user, one network, one MNT, one root file system, one pit tree, some CPU, some RAM. Agree with me? 111. Correct now? Look at this. This application required one user, one pit tree, one network, one root file system. Correct now? Hello?
Yes.
We should also remember that these all are coming from kernel. Now what is a kernel? So kernel is a what?
Kernel is the code that does all the processing, like communication processing.
Kernel is a what? Last session we discussed. I'm not discussing in detail, but kernel is a computer program, right? Correct now?
Yes.
Think simple. So kernel is a computer program So my thing is very simple. And kernel create user network MNT PID. So kernel, can you not think of kernel can create multiple user, multiple network, multiple mount means here I want to say multiple C drive, multiple PID tree. So theoretically, yes, it can. You run n number of time the computer programs, n number of times you get an instance instantiated. Very much possible. Agree with me, all of you? Hello, hello.
Yes, yes, we can hear you.
Yeah. So actually, can we create a multiple user in one operating system? Yes. Can you create multiple network? Yes. Can you create multiple C drive? I'm using C drive, so you'll remember MNT we call it technically. Actually, yes, but we don't create multiple MNT. Why? What you will do with that multiple C drive? PC concept. Remember personal computing. Linux and Windows design operating system for human, not for running a data center in 1970s, 1980s. Now we are running a data center because of internet, right? At that time it was not internet. So this architecture which we are using is their design from 1970s, 80s and all kind of things. So what this guy Solomon Hikes this suggested, this guy, this said, hey, let's do one thing. Let's have a hardware and then on top of kernel. Sorry. So this is the hardware and this is the kernel. Now this kernel, let's say, is Linux kernel. Linux kernel is developed by, I forgot the name, Linus Torvald, right? Yeah. So Solomon Hikes asked Linus Torvald. So Solomon Hikes asked Linus Torvald, hey Linus Torvald, can I create, think about it, simple. Can I create one pit tree? Can I create one network? Can I create one mount? So Linus said, yes, you can create, no problem. Linus Torvald said, can I create few more also? One, two, three, four, five. Said, yes. Linus Torvald said, yes, you can create. Now, when Solomon Hikes asked Microsoft Bill Gates means operating system Windows, then they denied, saying that no, we are closed kernel, we will not allow you to access it. No problem. So Solomon Hikes asked all this. So Solomon Hikes would develop one tool. Please understand this. This tool, it can run on the kernel. It's like a normal tool. Any tools which can run on a kernel, this tool. This tool will ask to create network, MNT, pit tree, and then user, and then user, and then user. Now
So when you say like
this,
multiple mount files, network, multiple
yeah,
PLDs.
yes, yes,
Okay.
yes. Now last thing, what this tool is asking, hey Linux kernel, can you assign this user with this pit tree, this mount, and this network? Linux did it. Linux did it. So now think about it. When you go inside this particular region, inside it, you will see the C drive, this one different, this is different, this is different, and this is different. this is different. Different network, different bit tree, and everything is different. So now, can you run this Apache here? 50 PID, C Apache, 80 port, 50 PID, C Apache, 80 port. Can you get it or not?
Yes, we can get it here.
Yeah. Here also there were 3 users. These 3 users are you and me, normal users. We are having only one network, one root file system, one pit tree. We are sharing the resources. These guys are not sharing. They have their own resources. So now you in this method, you can run multiple application isolated way. That means each resources, each user have their own resources. Now let's say you and me log into my laptop, you still will see the same C drive. But here in this case, this user will have a separate C drive and this user will have a separate C drive. Are you understanding now?
Yes.
Hello?
So they
So now,
customized Linux to run the containers, right, Rajesh?
huh.
Like,
So
okay,
so what do we call it this one? What do we call it? This one, what do we call it? So this is one container. This is one container, one container, one container. Who's managing it? This is a Docker. How many operating system you have in this? Tell me.
I
Only
think
one
I think there is
here.
a delay in your screen, and
Or is it for
I don't
everyone?
know, I don't know it's only for me or like.
So guys, this is the only one kernel you have, an isolated container you are running that is running your application internally. So guys, did you understand that, all of you?
Yes.
So this, they did nothing but played around with the architecture. So now
Okay.
they can,
Raj, can you explain me this? Like, looks like I just lost the connection and it got re-established. Can you explain the last couple of minutes?
so here that was a saying, this we call it a container. Each
Okay.
container is having their own network, own mount, own pit tree, and own user, and running independently, managed by kernel, managed by Docker and powered by kernel. Means kernel is basically is powering it, but based on the instruction with from Docker.
But every container will have only like common kernel, correct? Common kernel, but
You
only
see
the
that this is running from this kernel, this kernel, this kernel, correct? Common kernel, but multiple Apache. Each Apache will run on 80 port. Each Apache will be storing in a C Apache, but their own C Apache. So no conflict, and each Apache will have a PID 50 because they have each Apache, each container, they have their own PID ID and so on. Got it?
yes.
So this is called container. So what do we call it? Container is a lightweight application. Don't call it a virtual machine, okay? Because virtual machines you have operating system. Container do not have operating system. So container is a lightweight application runtime environment. Okay, got it? Lightweight means there's no kernel. That's the reason it's lightweight. So here you see that you don't need too many operating system licenses also.
And
Only
we have
one is
only one
sufficient.
operating system. Only, okay.
Yeah, yeah. And you can run as many containers you want in this box as the your VMs permit or physical server permits. Remember that Docker need only kernel. Kernel you can get in the VM also, and you can get in a physical server also. So you can run container any places.
So I have one question, but I don't know it's very early or something. But you say it has only one operating system, right? Like, so for example, if I do any patching for this operating system, all the containers will get affected in that.
Yeah, yeah. You have to stop it,
Okay.
and then, but you will not run in only one container in one. You will run container in multiple VMs. So that way, one patching is there, others will be available, right?
Oh, okay.
Okay. So now, guys, what is Docker? So Docker is a container management tool. Using that, you can create a container, start a container, stop the container, restart the container, pause the container, unpause the container, kill the container, remove the container. So yeah, the version which you see, I think is 22.x. I need to validate one more time. This tool is written in Golang. Okay. So this is something in Golang. Now see here, simple way. Docker is written in Go. Kubernetes is written in Go. Terraform is written in Go. Packer is written in Go. Um, Packer Vault is written in Go. Vagrant is written in Go. So yeah, many software is nowadays written in Go. So remember that. Okay. Now they have a release actually. One is a community release which I'm covering right now, and one we have a enterprise release also. Um, so now what is the difference between community and enterprise? You guys just Google it here. Docker community enter, and here you have Docker community enterprise editions and also. Okay, so all of you understood what is a Docker? Any questions?
No, no, Rajesh, so far all good. Yeah.
Okay, so now Docker architecture. So in a Docker architecture, every architecture actually, you are the one who's upfront, human. You will send a command to Docker client. Docker client send a command to Docker D, Docker server or Docker daemon. Docker D send a command to container D. Container D send command to kernel. So this part we call it Docker engine. Docker engine. Guys, Docker is not any product actually. Then you must be wondering how come you are teaching Docker then. So basically Docker is a company name, not a product name. And the product which I'm teaching you is Docker engine. Most of the time we call it a Docker. That means when people say Docker, they are basically talking about a Docker engine. As a Docker company, they have a multiple product, registry, Docker Swarm, Docker desktop. Many products they have it. Docker engine is one of the first popular product, so it's become Docker. So yes, remember the Docker client, Docker daemon. When you install, you get it. Now, what is container D? So this is the assignments to all of you. Take a note of for you. I want you to come back on to me and you need to tell me what is container D. Very important assignment. You need to find out and write a one post at a debug and then share with me. Okay. This is very important. I must tell you. Kernel, I taught you at a high level last session. So if you want a little bit more stuff, spend some time here. This we will install, we will get it. So this is the architecture. Are you understanding, all of you? Okay, how can I learn Docker? So guys, in order to learn Docker, you need to learn four components. First thing, install Docker, Docker engine. That I'll teach you the demo. The moment you install, you will get it here. Then guys, second thing is get a Docker image. Now you will think, what is Docker image? So guys, last session we created a VM from image. Which image? That was a machine image, ISO file. If you remember that, correct now? Correct now? Hello.
Yes.
Yes, yes.
So guys, in a Docker image, so same way, if you want to create a container, you have to have image. Then you will ask me, Rajesh, what is the difference between Docker image and the VM image? So let me tell you here. In the VM image, you have boot file system. Boot file system means kernel, and then we have a root file system. Okay, and then you have user file system, and then application file system.
So when we say
Example.
Docker image, the Docker engine is the Docker image, right?
No, no, no. Docker engine is a software which we need to install it. Docker image, we need it for creating a container. So this is the first element. Second element is Docker image.
Okay,
So
Docker
first
image
you
is
need to,
nothing but the Linux Docker, like
no, no,
the kernel.
I'm telling you.
Okay, sure, sure.
Yeah. So forget about the Docker image. VM image, machine image, AWS image, Azure image, VirtualBox image, which have tried it out. So here VM image has a boot file system, means kernel. Root file system, the one which I just now showed you, this one. Never forget conceptually this file system. Then user file system. Let me show you user file system. This is my file system. Only I can see that. Correct now? Not anyone else. Correct now? And then fourth one is application file system.
So is it,
What is that?
sorry, Rajesh, is it hidden or like nobody's can't see means? Uh,
Oh, I can see only. No other user can see. That is what I
okay,
mean. See,
gotcha.
I'm Rajesh. You are your name
Arun.
Arun. See, this is my
Yes.
file system. Can you see that as a normal user? No, I cannot see yours. You cannot see mine.
Okay.
Administrator can see everyone. Correct now?
Mm, yeah. Okay.
So like that. So that is a user file system. Application file system means any application, Notepad, Paint, or typically I install my application in C tools. See here, meter. This is the application file system. Okay. So in short, VM image you have a some application, some user, root, boot. Are you okay with it, right? Boot means kernel. Correct now? So in this case, in the VM image, a Docker image, you will have no boot, guys. Look at this image. This image have only root file system. So here, root file system plus one user and one applications or multiple applications can have. So if someone will ask you what is image, so you can say a Docker image actually. So you should say, hey, Docker image have a root file system, user file system, and application file system. It has no kernel, no boot file system. Okay, and Docker image in a form of layers that right now I'm not complicating. I will cover in one session upcoming. So yeah, second, so the question was how can I learn Docker? So first install the engine, I'll teach you. Then get an image. Then you'll say, Rajesh, from where we can get the image? So the concept is called registry, Docker registry. Docker registry have repository, and repository you have a version of file system is equal to Docker image. So this is the Docker image. So registry has a repository has version of file system and is equal to Docker image. So in this case, are we having any registry? where we have multiple repository which has a image. So one of which very popular is hub.docker.com, this one. So here, how many image you have? You have any idea? Look at this. More than 1 lakh image is there. See, BusyBox, Ubuntu is one image. Ubuntu is not operating system here. It has root file system, user and application. Python means one application, so it will have root plus user plus Python. Postgres, HTTPD. Lakhs of images are there. So from where you to download the image? From registry. And after downloading the image, the moment you run image, Docker image, okay, you get a container. Okay, so what happens? The moment you say, I'll give you simple command for that. Docker run image name. What happens? Docker client send the request to Docker D. Docker D check image in local, not found, download it. Full workflow I'm telling you. Download it from hub and then create one root files and one mount from image, one uh, one network with the help of Docker, one user and one Petri, and then all this thing combined into one container. This is what happens when you run Docker image, Docker run image name. Did you understand that, all of you?
Have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.